Brandon, are you
I
just
forgot how triangles worked on the PSA.
Triangles, right?
Yep.
I just assessed.
Hey, you're testing me or
Okay,
I just
So page
It has to be
26,
removed.
please.
I never said a specific problem, so I'm glad.
He's talking about the
Page 26. We're looking to look at example 5 on page 26. So we talked about synthetic division yesterday. You're going to have the remainder of the period to work on the synthetic division homework. I have a book up here that you can take a snapshot of, or you can use the online book, your iPad, either one of those works. But example 5, yesterday we talked about synthetic division. And if you get a remainder of 0, that tells us what about what you were trying to divide with, Brandon?
That whatever you're trying to divide with is a factor.
Correct. Whatever you're trying to divide with is a factor if you get a remainder of 0. So we are going to try and divide those two factors and show that they are factors, they are zeros, because the remainder should be 0. However, we're going to do this successively, which means we're going to take the first 0 and we're going to divide with it, or the first factor, and divide with it. And then we're going to take the answer that we get, and that's going to become our second synthetic division problem, and we're going to use the second factor to divide. So our goal in this section is to find all of the zeros. Tomorrow we're going to work on problems where we kind of divide one after the other in order to break down a power as far as it can go so that whatever is left is factorable. So we're going to try the first one. There we go. So with synthetic division, what number goes outside? What number are we dividing with? 2. So we'll place the 2 outside. The coefficients go at the top from the polynomial that we're working with. And then our remainder goes underneath the last term, which is the negative 18. So Libby, just a refresher from yesterday, what do you do with the synthetic division?
You bring down the 2.
So always bring down that first number, and then?
Then you bring it like diagonally.
Good. And?
You multiply it with, or wait,
You're right.
yeah, multiply it with the number of, or with 2, and that's 4.
Right. So you're taking the number at the top left, the number underneath the bottom row here, multiply those together, you get 4. And then you add vertically. So 7 and 4, Libby, make
11.
11. And then do it again, Libby.
You would bring it up and get 22.
And add negative 4 and 22, which makes?
18.
Okay. So then you get?
Is it 36?
Yeah.
Yes. Sorry.
That's all right.
It was a long day. It's okay.
And negative 27 plus 36 is 9. And then one more time, 2 times 9 is 18, but negative 18 plus 18 gives us a remainder of 0. Which if it's a factor, that's a way to prove that it's a factor, having a remainder of 0. It also means that it's an x-intercept. It's a solution. It's a remainder of 0, so it's an x-intercept, solution 0, any of those work, factor. So then we are taking this answer. If you divide, the goal of dividing is to break a problem down. If we started with x to the 4th, this answer would be x cubed, x squared, x, and then the 9. What we're going to do is take those coefficients and just bump those coefficients, the answer that we just had, into a second synthetic division problem. So I'm going to take the 2, the 11, 18, and 9 and divide with those. Because this is still equivalent. Just because I factored out an x-intercept or a 0 doesn't mean I'm changing the x-intercepts. So we just pulled one of them out. So now we want to show that the other one is also a factor, but this time it's a negative 3. We can't use the 2 because we already pulled that one out. So now we're going to see if negative 3 is a factor or an x-intercept as well. So you're taking the answer, we're using the answer as our quadratic division problem. So Sabrina, we bring down the 2.
And then you have to make that a -6 when you bring it up.
So a -6. Combining those together give us,
Also,
okay? And then
you do 5 times -3, which is -15, which is a 3. Then you do 3 times -3, which is -9, because they're near 0.
the remainder of 0. So what is left? Can you tell me that equation that's left, Sabrina?
2x squared plus 5x plus 3.
Nice job. So our second problem, we started with x to the 4th, then we had x cubed, so now we broke that x cubed down to have an x squared. So it says to factor this completely, so we're going to take the result that we found after dividing twice. We broke it down twice, each time we're losing a power. We divided it with one factor of x plus 3 and another factor of x minus 2. And the goal is to factor this completely, meaning if the power is 4, can we get the 4 zeros? And we have 2 of them that we've shown are zeros by getting a remainder of 0. So just a little refresher with factoring. A times c is 6. We want to add to be 5. Well, 2 and 3 add to be 5, multiply to be 6. The AC grouping says to take those values and rewrite our problem. And then pull out what the first 2 have in common, pull out what the second 2 have in common. And then group the pieces together. So our factored polynomial would be x minus 2, x plus 3, 2x plus 3, and x plus 1. Completely factored means the problem should be broken down as far as it can go. In this case, they're all linear, because something that's linear cannot be broken down any further. Something that's quadratic can be, because we can factor it, we can use the quadratic formula to break it down. So the final part here says, what are the 4 real zeros Michael, what do you get for the 4 real zeros?
2, -3, -3 halves, and -1.
Yeah. So hopefully you heard him. He said 2, -3, -3 halves, and -1. Those would be the 4 real zeros. So that's called successive synthetic division. So you're doing one after the other, but you're using the answer, pulling that answer, and then dividing again. That's what we'll really be focusing on tomorrow. So the remaining 20 minutes are yours to get started on the homework.